Today's video is about section 4.3. We're going to skip ahead and talk about right triangle trigonometry. Now, trigonometry, as we talked about in geometry, is the study of angle measurement in triangles. And more specifically, comparing the angles to the sides and ratios. And in trigonometry, you have what are called trigonometric ratios. You have 6 of them. In a right triangle, those 6 ratios are defined as follows. If you look at a right triangle, think about the parts of a right triangle. You have the leg. You have another leg. You have the hypotenuse. And the 2 angles that are not right angles are acute angles. And we'll call theta here one of the acute angles. Now, based upon this acute angle, you have 6 trigonometric functions or ratios. You have the sine of theta, which is basically the opposite side over the hypotenuse. You have the cosine of theta, which is the adjacent side over the hypotenuse. You have the tangent, which is the opposite side over the adjacent side. And then you have the reciprocal functions. You have the cosecant. That's what CSC means. And it's just the reciprocal of the sine. So the cosecant, if the sine is hypotenuse over opposite side, then cosecant is hypotenuse. Or sorry, the sine is opposite side over hypotenuse. The cosecant is hypotenuse over opposite side. Likewise, the secant, S-C-A-N-T, of an angle is just the reciprocal of the cosine. So you have the hypotenuse over the adjacent side. And the reciprocal of the tangent is what's called the cotangent. And instead of opposite over adjacent, it's adjacent over opposite. Those are the 6 trigonometric functions, and basically how you would find them in a right triangle is you would look at the acute angle here, whatever it is, and basically you would go with the ratios. So for example, if I said find the cosine of theta and I had a right triangle here and theta was right here and I said this was 5, 12, and 13, then the cosine of theta would be the adjacent leg or side, which is 5, over the hypotenuse, which is 13. And that's how you deal with the trigonometric functions. Now, one of the ways we taught you in geometry to remember trigonometric functions is SOHCAHTOA. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So the sine, the opposite over hypotenuse, is where the OH comes from. Cosine equals adjacent over hypotenuse. That's where the ca comes from. And tangent equals opposite over adjacent, and that's where the TOA comes from. So that's how you get SOHCAHTOA. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. Now, an example of what you would have to do is basically if you have a right triangle here, and let's call this theta, and let's say this is 3, 4, and this is C. Well, first step in doing a problem like this is to find the missing side. And how are we going to find the missing side in a right triangle? Yep, you guessed it, we're going to use the Pythagorean theorem. So we're going to go 3 squared plus 4 squared equals c squared, because remember you set it equal to the hypotenuse squared. And 9 plus 16 is c squared. 25 equals c squared, so 5 equals c. So now the question says to find the trig function. So we're going to find the 6 trig functions based upon using theta here as our angle. So sine of theta, well, it's opposite over hypotenuse. So the opposite side from theta is 4, the hypotenuse is 5, so it's 4/5. The cosine of theta, well, remember it's adjacent, and remember adjacent non-hypotenuse, so the adjacent here is 3, the hypotenuse is 5, so we're talking 3/5. The tangent of theta is opposite over adjacent, so opposite is 4, adjacent is 3. Now, for the cosecant, remember, it's the reciprocal of the sine. So you could either do hypotenuse over opposite, or you could just take the reciprocal of 4/5 and get 5/4. The secant is the reciprocal of the cosine. So you could either do hypotenuse over adjacent, or you could just take the reciprocal of the cosine, which is 5/3. And cotangent is the reciprocal of the tangent, and so that would be 3/4, or adjacent over hypotenuse. So let's do another one of these. So let's call this 1, the hypotenuse 5, here's our right angle, and here's theta. And remember, it says to find the value of each of the 6 trigonometric functions in simplified form. So for example, first of all, we have to find the missing side. So we'll do 1 squared, and we'll just call this b, plus b squared equals 5 squared. One plus b squared equals 25. So b squared equals 24. So b equals the square root of 24, which simplifies to 2√6. So when I find the sine, cosine, and tangent, so sine of theta, remember, is opposite over hypotenuse, so that's 1/5. The cosine of theta is adjacent over hypotenuse, which is 2 square root of 6 over 5. The tangent of theta is opposite over adjacent, which is 1 over 2 square root 6. Now remember, you cannot leave a radical in the denominator. So we got to rationalize the denominator by multiplying top and bottom by the square root of 6. So we get the square root of 6 over, well, now remember, when you multiply square root of 6 and square root of 6, you get 6 times 2 gives you 12. So it's the square root of 6 over 12 would be our final answer for that. Now, for the reciprocals, the cosecant, is just 5, because 5 over 1 is 5. The secant is where it gets a little more dicey, because reciprocal of that is 5 over 2 squared 6. So remember, we rationalize to get 5 square root 6 over 12, because the square root of 6 times the square root of 6 is 6, times 2 is 12. And then the cotangent, well, when we take the reciprocal of the original here, that's just 2 square root 6. Now, there are some special angles, like if you remember 45, 45, 90 right triangles from your geometry days. Remember, for 45, 45, 90, you have the two legs are the same, 1 and 1, and the hypotenuse is the square root of 2 times larger. So, if you do sine 45, well, opposite over hypotenuse is 1 over the square root of 2, which equals, when you rationalize it, which is the square root of 2 over 2. Cosine 45, doesn't matter which 45 we use, so let's use that one. 1 over so the adjacent is 1, the hypotenuse is the square root of 2, so it's the same. So when we rationalize it, we get the square root of 2 over 2. The tangent of 45 is 1 over 1, opposite over adjacent, so it's just 1. Now the next special right triangle is what's called a 30, 60, 90. So let's say that's 30 and that's 60. Now remember, the 30 is the smaller angle, so this is the smaller leg. The 60 is the larger angle, so this is the larger leg. And then the hypotenuse. Well, remember, the smaller leg we call x. The larger leg is the square root of 3 times x. And then the hypotenuse is 2x. So when we talk about the ratios, we say that the smaller leg is 1, the larger leg is the square root of 3, and the hypotenuse is 2 when we deal with the ratios. So, for example, if I want to find sine 60, I look at the 60-degree angle and I say opposite over hypotenuse is equal to the square root of 3 over 2. If I want to find cosine 60, I do adjacent over hypotenuse, so it's 1/2. If I want to do sine 30, I look at the 30-degree angle up here, and I say, okay, opposite over hypotenuse is 1/2. Cosine 30, adjacent over hypotenuse is the square root of 3 over 2. Notice the sine of one of the angles is the cosine of the other, and the cosine of this one is the sine of the other, and vice versa. That's what happens in one of those special right triangles. Now, we can solve word problems using trigonometry. And for example, here we're going to use what's called the angle of elevation. So here we're using the top of a building. A surveyor measured the angle of elevation to be 22 feet. So let's say we have a surveyor here, this nice drawing, and he looks up at the top of a building, and the angle of elevation that he looks at the building is 22 degrees. The transit, which is the device that he looks up at the building, so there's like a little transit here, is 5 feet above the ground. So it's 5 feet above the ground. And 300 feet from the building. So 300. Notice I'm drawing a little triangle. So here I have a right triangle here, if you notice. To the eye level with the transit, angle of elevation is 22 feet. And I know it's 300 feet from the transit to the building, or from the surveyor to the building. So it says to find the building's height. Well, first of all, I can find this little piece here I call y. And then at the end, I can add 5 to find the total height. Well, I can use a trigonometric ratio because notice I have 22 degrees, y is opposite, the 300 is adjacent. So I'll just take the tangent of 22 degrees is equal to y over 300. Now, when I type this in my calculator, first of all, I can multiply by 300 to get y by itself. And 300 times tangent 22, that's equal to y. So basically, it's about 121.2 feet when you put it in and get that. Now, so I drew the picture and I set up a trig ratio to solve for the missing side. Sorry, I skipped ahead. And then I take the 121.2 and I add 5 feet to it, and I get 126.2, and that is the height of the building. Because what I found originally was just from here to here, then I have to add the 5 feet for the little pole that the surveyor looks up at. So my total height of the building is 126.2 feet. If I needed to find an angle, I will use the inverse key on my calculator. So notice, if you look at your calculator and you go second function, you hit the little second function key, and then you hit the sine key. That is the, it says up above, it says sine inverse, and that's what you're going to use. So when you find, when it says sine theta equals 0.54321, really you want theta is equal to the sine inverse of 0.54321. So when you type that in your calculator, you should get about 32.9 degrees. If you hit second function sine and then 0.54321. The reason you need to know how to find an angle is because you'll do word problems sometimes where the angle is missing. So for example, you have a building here that is 21 meters tall, and it casts a shadow. It casts a shadow and you want to find the angle of elevation to the sun. So let's say the sun is over here. Nice sun. So basically, you set up a trig ratio after you draw the picture. So notice at theta, you have opposite and adjacent. So you're going to use tangent. And the opposite is 21, and the adjacent is 25. Because remember, tangent is equal to opposite over adjacent. Now you're trying to find the angle, so theta is going to equal the tangent inverse of 21 over 25. So you type that in your calculator. Remember, you hit the second function key, and then you hit tangent. And it should give you tangent inverse 21 over 25 on your calculator. And when you type that in, you'll get that theta is approximately 40 degrees. It says 39 point something, I think, and you round it to 40, or it might say 40.1. And because it wants to the nearest degree, it is 40 degrees. This concludes our video. Hopefully you enjoyed it, and I will see you guys on Thursday. Any questions, please let me know. Thanks.